Okay, so as we talk a little bit more about electrons and how they interact with each other, one of the things we'll talk about is the type of bonds that they could make. And so here we have two different type of bonds, examples that we're going to talk about. And the first one we're going to do is a bond type in which electrons are shared. And because they're shared, the easy way to remember is that when you cooperate with someone, you end up sharing. And so these are covalent bonds. And just remember, co's and cooperate is in share. And so they're going to share the electrons. They're not going to take them from each other. They're just going to share. And our example of this is going to be oxygen. Well, technically this is atmospheric oxygen. So this is the oxygen as it exists in the air that we breathe. You see the little O2 tanks on like the older people who have to wear the gas mask and they get their oxygen. You see the O2 tanks, or whenever you go scuba diving, you see O2 tanks. O2, that means it's two oxygen atoms that are bound together. And how are they doing that? Well, they're actually sharing atoms. So oxygen has 8 protons, so it has 8 electrons. That'd be 2 on the first orbital and then 6 in the outer. Well, they only need 2 more to have an full outer shell. But what they do is this little phenomenon that they go through where they'll bond together, and they actually end up overlapping their outer orbitals. And you'll notice I had to draw this little piece in just because of the way that it worked out whenever I printed it. But that's okay, we still got it. So let me change these colors here, and let's put the electrons where they're going to go. Okay, we said we had 8. This one also has 8. If it had 10, it would have a full outer shell, but it's got 8, so it's going to be missing 2. So let's look and see where these are going to go. Okay, just like before, we have 1 here. Let's refill that sucker in. There we go. We've got another one there. Now this one's going to go here up top, so that's 3. Now watch where I'll put these next ones. These 2 are going to go over here. Well, that one is, so it's 1, 2, 3, 4. Here's 5, 6, 7, and here's 8. Okay? Notice that these 2 that I just put on are kind of closer to this guy. All right? So where would this guy's 8 electrons be? Well, 1, 2, right, 3. And instead of going this direction just for the purpose of here, usually we add to the right. We're going to go this way just to show. Hey, look. Technically shouldn't have added that one yet, but that's okay. There we go. And I think that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. We need one more. We'll add it on top. There we go. That makes that makes 10. Well, this is 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. But if you look at it like this, take this 1 right here. Okay. Count all of the electrons that are inside of its outer orbit. So 1, 2 in the first in the s orbital, 3, 4, 5, 6, 7, 8, but these 2 are on the inside, so it feels like he has 9, 10. He feels like he has a full outer shell now. The same thing with this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He feels like he has a full outer shell. Ooh, interesting. But does he really? Well, no, he only has 8. He's still missing 2, but because they've overlapped with each other, they feel like they're getting a little bit of the electrons from the other one, but they're not taking them. These 2 electrons still belong to this molecule, or this atom, and these 2 electrons still belong to this atom. So really, they're just sharing the electrons, and that forces them to want to stick together. And this is what atmospheric oxygen is. This is the oxygen that you breathe. Oxygen is actually pretty destructive by itself. Those 2 little electrons that it's missing, it can actually rip that off of iron. You know why iron rusts, right? It gets exposed to the air, and the oxygen reacts with the iron and rips off pieces of the iron and binds with it, causing iron oxide. And iron oxide is rust. And you see how much, how structurally bad rust is for something. Right, so let's move on down just a little bit to this next one. So this is going to be, electrons are not going to be shared in this case, they're going to be taken, right? They are shared with oxygen, but they're not going to be shared down here. So this is what we call an ionic bond, and it's where electrons are taken. In our example, we did this earlier. This is our NaCl, right? And this is salt. And you've all seen salt before. Got to have it in our bodies for lots of different processes. So a lot of water has salt in it. Your sweat and your urine both have salts in them. Okay, so what we're going to do is this is going to be our sodium. So here's our Na. Here is our here is our Cl, our chlorine. And what we've already got drawn is kind of what's already kind of taken place here. Is one little thing I need to do, and that is that it's missing an orbital. We'll open it up just here in a minute. Let's get that no fill. Whenever I put it up, I, for whatever reason, was missing an orbital. So I'm just going to add it in here so it looks pretty good. All right, so sodium, like we said earlier, has 11 protons, so 11 electrons. And chlorine has 17. But we're not drawing the regular atoms, we're drawing the ions. I just realized I spelled this correctly, I apologize. I-O-N-I-C, I don't know, we got this, hang on a second. You're probably sitting there, you drew it wrong, what are you doing? And I still don't even know what I'm doing. Let's see, copy, paste. If you've never worked with paint before, this is a good trick for erasing stuff. It just makes it easy. Ta-da! And then I can come back in here and type it. This is an ionic bond. Make him look a little pretty. There we go. Close enough. Ionic bonds. All right. So down here with this ionic bond, so we're making ions. Okay. The sodium had one in its outer shell. It's lost that, so it has its electrons should have 11, but it's only going to have 10 because it's missing a negative charge. It's going to be positive because it's missing an electron, missing a negative charge. And using the style we've used before, I'm just putting them where they go. And there they are. There's our 10 electrons. But keep in mind, he's supposed to have 11. So he is now, let's see, he is now very much positive. Right? So what about our chlorine? Well, our chlorine, if you remember, he ended up being negative. So where were our electrons in here? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here's our 17th one. There should only be one here, but he's an anion. He's got an extra one. Just so happens, where do you think chlorine got the extra one from? Well, sodium had one extra. Chlorine needed one, so chlorine usually just takes it from sodium. And because they're right, and as soon as they do, they become charged. As soon as that electron taken, you now have a magnet. Because they're right there next to each other, they instantly stick together. So you get NaCl. They stick together like magnets. And that's where salt comes from. That's how salt is actually made. So if you didn't know that, now you did. I'm going to highlight this little guy so you know, hey, he was the one that was added. He actually came from, he was over here in the outer shell, technically do that color, and has like a little bow to it. Here's the other orbital from here. There we go. See, I'm getting better at making curves. Y'all can't laugh too hard at me. I mean, go ahead and laugh. I am pretty silly. But this is where he was. Let me get those colors back to where I need it. There we go. He does not want to stay that color, does he? Oh well, we'll just say that's our electron. And what happened to him? Well, I'm going to do a free draw. There we go. There he went. He left sodium and went to chlorine, causing this one to become positive because it lost a negative charge, causing this one to become negative because it gained a negative charge, and they instantly stick together. And that bond type is called an ionic bond. They are ions, they're magnets, they stick together. And that's two of our big type of bonds, covalent bonds and ionic bonds. Now, we have one more to talk about that's important for life, and that's going to be our hydrogen bonds. And we'll get to that in just a second. But there's also another type called metallic bonds, which we really won't talk about in here. That's more of a inorganic chemistry, kind of like higher level chemistry. But no, there's only really so many bond types that are out there. Most of us are put together and held together by covalent and ionic bonds. Our hydrogen bonds, we'll look at in just a little bit, do help. But for the most part, it's a lot of covalent bonds. They're pretty strong, covalent and ionic bonds. But sometimes we do need to break things open, so it pays to have a weak bond or a weak attraction that we can actually break pretty easily. And that's what we'll look at in just a second when we talk about the hydrogen bonds.